going to be learning how to graph exponential functions, which we dabbled in a little bit in 14.3, but today we're just explicitly learning how to graph these exponential functions. So just as always, whenever we're graphing any sort of function, we need to create an input-output table. So that's what we're going to do. And then from there, we're going to identify the y-intercept, the a value, the b value, and also the end behavior. So I'm just going to go jump into the input-output table. Hopefully you guys have a good understanding of how we create an input-output table. So I got my input values, -1, 0, 1, 2, and my output values are whatever f of x is when x is the value in the input table. So for the first one, 2 to the -1 power is going to be 1/2. 2 to the 0 power is 1, 2 to the 1 power is 2, and 2 to the 2 power is 4. So now that I have created my input-output table, I just got to graph those points. So my first point's at -1, 1/2, 0, 1, 1, 2, and 2, 4. There we go. And then I can go ahead and draw my line. Oops. All right, so now I need to start identifying things. Well, the y-intercept is where the line crosses the y-axis, which is right here at 0, 1. So the y-intercept is 1. The a value is, I can just actually look at the equation. The a value, there's nothing in front of the 2, so the a value is also going to be 1. And then the b value is the base of the exponent, which is 2. So those are all things I can actually derive from the equation. And hopefully you can, we'll see a pattern emerge between the y-intercept and the a value. Finally, I have to describe the end behavior. Now, the end behavior is what is happening to the function as it goes off to -infinity and as it goes off to +infinity. So as x approaches -infinity, if you notice as x approaches -infinity, this graph is actually going to get really close to 0. But it's never actually going to reach 0. Even if I had -1074, my function would just be 1 over whatever 2 is to that power. So it's not going to be 0. It's just going to get to become a very small fraction. So as x approaches infinity, f of x will approach 0. And this is kind of the sentence frame that we're going to be using. And then as x approaches +infinity, f of x, so looking at f of x is also going to approach +infinity because it's going to get infinitesimally larger. It's going to shoot straight up. And so this is just how you describe end behavior. You say, as x approaches -infinity, what's going on? So remember, x is the horizontal axis, and as x approaches +infinity, what is going on? Okay. All right, and let's look at b. So b, I have f of x equals 3 times 4 to the x power. So same thing, just going to create my input-output tables. So 4 to the -1 is 1/4. So my first value is going to be 3/4. And then I'm going to have 3, 12, and 48. Which I will definitely not be able to graph today. It looks like actually I'm only going to be able to graph are these two values, the 3/4 and the 3. So let's go ahead and graph those values. So -1 3/4, 0 3, and 112 I can kind of guess is going to be up here. So I'm going to expect my graph to actually make this shape up here. So again, if you just plugged in a random x value that's negative, you would find that on this end right here, as it approaches -infinity, it's going to be flattening out at 0 again, right? Just again, think of a fraction. What's happening with the base, we're always going to have 3 on top, and there's no way I can have 4 to a negative exponent, that's going to equal a value bigger than 3. Unless it's -1, which would be right here. Just still above that line. So then now we have to start describing the y-intercept and the end behavior. I'll fix it, okay? You gotta give me a minute because I gotta tape it. All right, so y-intercept is, it's kind of wobbly there, but it's 3. It's in the, if I look at the table does a better job at identifying the y-intercept. The a value is also 3. It's the number in front of the equation.
int colon a colon.
Ooh, that was exciting. I didn't want a text-to-speech. You know what I wanted was my text box. So you guys all got to enjoy that. And then b is going to be 4. And then again, describing the end behavior, I'm actually just going to kind of copy and paste this because I like to be lazy. So this works out because as x approaches infinity, it does end to equal 0, and as x approaches positive infinity, it's going to, f of x is going to equal approach positive infinity. So it's actually the exact same thing. If we look at our graph, like, it looks different, but it has the same layout as example A. It's just been shifted over and stretched out a little bit. All right, let's look at this one. So we got -2 times 3 to the x power. So let's go ahead, create our input-output values. -2 times 3 to the -1 is going to be -2 thirds. -2 times 3 to the 0 is just -2. -2 times 3 to the 1 is -6. Oops. And -2 times 3 squared is going to be -18. I got my input-output values. Let's graph them. -1 to the -2 thirds is going to be down to here. 0 to the -2 is right there. 1 to the -6 is down here. And that's as far as I'm going to be able to go today. So let's go ahead and connect these dots. All right, so this graph has a little bit different end behavior. So let's go ahead and, well, first let's identify the y-intercept, and then we'll go back to identifying. So y-intercept is -2, a is also -2, and b is 3. So hopefully you are able to see that the a value is actually just the y-interceptance, because whenever you plug in 0 for an exponent, you're just going to end up with 1, which will just leave you whatever the a value is. So the y-intercept is the same thing as the a value. So hopefully you're able to kind of establish that pattern on your own. But now we can talk about the end behavior of this function. So let's, use our copy and paste tools. Let's talk. So as x approaches -infinity, it is still, f of x is still going to approach 0. It's just approaching it from below. So this actually checks out. But however, as x approaches positive infinity, so as x goes to the right, notice that our values are not increasing, they're actually decreasing. So instead of approaching positive infinity, this time we're actually going to be approaching negative infinity. And what this tells us is that if you had nothing to go off of, then if you just described the end behavior, then I know an exponential function is going to flatten out on one end and then increase exponentially on another. This would give me an idea of what that function would look like. So that's why we like to describe the end behavior. All right, last one, I have f of x equals 0.5 to the x, and I'm actually going to think it of as 1/2 to the x. I know you guys don't like fractions. It just makes it easier on my brain if I think of it as a fraction. So 1/2 to the -1 is 2. 1/2 to the 0 is 1. 1/2 to the 1 is 1/2. And 1/2 squared is 1/4. All right, so y-intercept, I'm going to identify all these things without graphing. So y-intercept 1, right? A value is also going to be 1. And then the b value is 0.5, or 1/2.
Mommy, I've never seen this. Mommy.
That's so silly. It's such a cute little kitty cat, huh? Oh, little puppy. Alrighty, and if I graph those points, this is what it looks like. Okay, so let's describe that end behavior. I want you guys to pause it and see if you can describe the end behavior on your own. All right, and now we're going to actually tell what the end behavior is. So this time, as f of x approaches, so as x approaches a negative infinity, my graph isn't approaching 0. My graph this time is actually approaching positive infinity. It is going up on the left. And on the right, as x approaches infinity, positive infinity, so it goes on, this time it's actually approaching 0. It's starting to flatten out. So now I've determined my end behavior. I've identified the important information. We just graphed exponential functions, guys. Good job.